So I thought that as programmers, we had collectively agreed that we're supposed to be uploading a new Git tutorial every 4 to 6 months, yet the most recent one I see was 8 months ago. So I gotta hey bro, yeah, what's good? Did you try using the recently uploaded filter? Anyways, I got us this time, and listen, I'm sure you got stuff to do, I got stuff to do, so let's speedrun this. Okay, first of all, what even is Git? Git is what's known as a distributed version control system, but what does that even mean? Well, there's really just two parts to this, distributed and version control system. Let's start with the distributed part. Let's say you decided that you want to contribute to an open source project that's on GitHub. Well, when you copy the project over to your machine using Git, it doesn't just copy over the current version of the files, it copies their entire history as well. This results in the project living on several machines, which provides better reliability due to redundancy and allows you to work locally. Now, over to the version control part. Version control is just a system that tracks changes made to a project and allows you to roll back to previous versions. It also lets you see exactly who made which changes, which is pretty useful for knowing who implemented the 10.0 CVE and then terminating them via email. Okay, so now that we know what Git is, how do we actually begin using it? Well, first, you're gonna have to install Git on your computer from the official website. I also put the link down in the description. So just follow the instructions for your particular operating system, and then once you have it installed, you should be able to just run git -- version in your terminal. And if you see the following, I'm sorry to tell you, you have successfully installed Git and there's no turning back now. Okay, so in order to create a Git repository on your computer, simply open an existing project or create a brand new one, and with your terminal path pointing to the root of your project, run git init. This will initialize a Git repository by creating a .git folder with everything Git needs to version control your project. Now, you'll notice that the files in your working directory just got tagged with a U, which means they're currently untracked. So what does that even mean? Well, in order to answer that, first we need to define the three main areas of Git: the working directory, the staging area, and the repository. The working directory is just a folder where your project files live, so basically just the left sidebar in your code editor. Now the staging area holds any changes you made that you want to include in your next commit, and the repository is where your commits get saved. So the workflow is as follows. We have our project files, and when we make updates to one of them, for example index.html, we stage that file by adding it to the staging area, and once we've staged all the files we want, we package them inside of a commit, which will be recorded in the repository. So what's a commit? Well, it essentially represents how your project looked at one point in time by containing a snapshot of all project files being tracked by Git, but it also contains metadata such as the author, the timestamp, a commit message, as well as a pointer to the previous commit, which is how we end up with the Git graph that you're used to seeing. Okay, now let's rewind for a bit and answer the question that sent us on this little journey in the first place. Now, you'll notice that the files in your working directory just got tagged with a U, which means they're currently untracked. So what does that even mean? According to Git, an untracked file is a file that has not yet been staged or committed. So if that's what an untracked file is, can you guess what a tracked file is? Exactly, like and subscribe. Now this is all good and well, but like Lil Wayne said, today I went shopping and talk is still cheap. So let's see how this actually works in practice. So let's start by asking Git where our files are, and to do that we run git status. So we can see we have our 3 untracked files, so let's stage them by running git add period. So once I run this, I'm gonna run git status again to see how our files have changed, and as you can see, they're now under changes to be committed, and Git also gives us instructions on how to unstage them if we needed to. Also, you can see that the U label has updated to an A, which just means new files have been staged. So to commit them, we can run git commit -m, and -m is just a flag that tells Git that we want to include a commit message with this command. So here you just want to include a short message that describes the work you did, for example, implemented login logic. However, since this is the first commit, we can just write initial commit. Also, make sure you always run this command like this. Never run it like this. If you run it like this, I cannot help you. Okay, so now I'm going to run this command, and as you can see, our files have been committed. And now that Git is tracking our files, if I change one of them, that's awkward. Okay, there we go. So now if I save this, you can see an M appears next to the file name in the working directory, which just means modified, aka Git sees there are new changes to be committed. So now that we know the basics, we need to learn about another concept, branching. So in Git, you have what are called branches, and you can think of them as variants of the same project. When you initialize Git and make your initial commit, this establishes what is known as the main branch, and any subsequent commits would belong to this branch. However, Git allows you to create new branches at any point in development to let you implement code that is isolated to that new branch. So why is that useful? Well, typically the main branch is meant for your production-ready code, and anything that is in development should be on a separate branch until it's ready for production. Now, that just leaves us with one question.
Where is Spider-Man?
Sorry about that. Let's see how branching works in our project. So like we discussed before, by default we are on the main branch, and in order to create a new one, we run git branch and then the name we want to assign it. In this case, I think our to-do app needs a delete button, so let's name this branch delete to-dos. Now, to see all your branches, you can run git branch, and as you can see, we're still on main as denoted by the green text and asterisk next to it. We only created the delete to-dos branch, but we haven't actually switched to it. So to do that, we run git switch delete to-dos, and then I'll run git branch again, and as you can see, delete to-dos is now green, and the asterisk has moved as well. And now to actually write the code. It's literally just a delete button. Okay, there we are. And by the way, this is our app. You're responsible for this too.
What the fuck? Stop playing!
So let's commit this code by running git add and git commit. And now if you look, when I switch back to main branch, the code for the delete button disappears. So how do we add it to main? Well, we can do that via merging. So let's run the following command, git merge delete to-dos, and the way that it works is that it will merge whatever branch you specify to the one you're currently on, aka the target branch. So since we're currently on the main branch, it will merge delete to-dos into main. So I'm going to run this, and you can see that the delete button code reappears. And I should also mention that there are two types of merging. There's fast forward merge and merge commit. And you can see here, Git pointed out that this is a fast forward merge. So let's go over why that is. So far in our project, we've made 2 commits on main and then branched off into delete to-dos where we made 1 commit and then merged it back in. And the reason Git said that this was a fast forward merge is because after we created delete to-dos, no additional commits were added to the main branch. So Git can just take this commit and bring it directly into main. So it basically becomes this. Now, a merge commit occurs when we merge a feature branch and additional commits have already taken place on main since the branch was created. So what ends up happening here is that Git creates a new commit that effectively combines the changes from each branch. However, you still run the same command, so to you, everything is still the same. So why do I bring this up? Well, it's because this can happen with a merge commit, a merge conflict, and if you can't resolve these, forget being a 100x engineer, you're a 0x engineer. So welcome to the club. Now, why do merge conflicts even occur? Basically, if the same block of code was modified differently in each of the branches, Git won't know which change is the correct one, so it returns a merge conflict to let you decide what to keep and discard. So let's just see a quick example of this. Let's create a new branch and call it fix delete button and change the functionality so that it will delete all the to-dos rather than just the last item in the array and commit the change. Then back on main, let's make it so that instead it will remove only the first item in the array and commit that. Now let's merge the 2 branches, and what do you know? We have a merge conflict. So in VS Code, you have 3 main ways to resolve this. You're not a part of this video. Accept current change keeps the version from the branch you're currently on, while incoming change keeps the version from the branch you're merging in, and accept both includes all changes from each branch. So in this case, I'm going to select accept current change, and as you can see, our code for removing the first element stays, and the change from the other branch is effectively discarded. Now all we need to do is commit this, and the merge conflict is officially resolved. So this pretty much takes care of our Git crash course. However, I just can't help but feel like this video wouldn't be complete unless we talked about him. But we gotta make this quick. So everything we've done so far has been local to our machine. So how do we share our Git repo with other devs to start collaborating? Well, that's where GitHub comes in. So what is it and how is it different from Git? No, but that's right, it's an online platform that can host Git repos for collaborative work. When it's actually working, that is, but anyways, let's see how to upload our project to GitHub. Okay, first you'll have to create a GitHub account, GitHub link in the description. So once you've done that, you want to click on this plus icon and then click new repository. So once you're on this page, you'll need to type in the name of the remote repo here. So in this case, I'll do Git tutorial and then choose whether you want to make this a public or private repo and then click create repository. So then we'll have these commands down here and we want to push from an existing repository. So let's copy this first command and then back in our terminal, let's paste it. So essentially this command just links the remote repo to our local one. The base command here is git remote add, and then origin is just the nickname of the remote. And lastly, you'll just need to include the URL. So we can run this and then do git push-u origin main. What this will do is upload our local main branch to the remote. So let's run this. And now if we look on GitHub, we should see our to-do app on there. And indeed we do. And now anytime we need to push new code to GitHub from our local main branch, we can just simply run git push. Now, let's talk about PRs, aka pull requests. They're basically GitHub's way of reviewing and merging branches, so let's just jump right in to see how they work. First, I've created a new branch called include date, which just allows us to include a date with a to-do when we add it. So let's upload this branch to the remote repo by running git push-u origin, and then the name of the branch we want to upload, and jump back over to GitHub. Here we can see a notification of the branch we just uploaded, so let's click compare and pull request and then click create pull request. Now, when you receive a PR, you'll always want to make sure you review the code before you merge it in, and since we know my code is trash, it still doesn't matter, it's my repo. So here we can see that there are no merge conflicts, so the branch can be automatically merged in, and you can also check to see who opened the PR as well as what's going to be merged. So now let's click merge pull request and then confirm merge. Now we can see that the two branches have been successfully merged. However, if we take a look at our local repo, we can see that the new code is not there on the main branch, and that's because pull requests that get merged in do not automatically update here. For that, you have to run git pull, which fetches any new changes from the remote branch and immediately merges them in. So let's run that, and there we go. Our new code is now in our local main branch. So yeah, that should be enough to get you started, and well, you know what else you need to do.